Hello friends, welcome to the second chapter of this course. In this chapter we will learn how to model a simple beam, and we'll also learn how to apply the load to the beam and analyze the beam and see the results of the analysis. So let's move on. As I told you in the previous chapter, so do a configuration if you haven't done. So after you have done the configuration as per your country or as per your requirement, so click on new project over here. So let's click on new project. So we'll choose the space option from here, and let us name this as the beam practice. So choose any appropriate location in your hard disk. Choose the length of the unit that you are comfortable with. So I'll choose the meter option. Also choose the unit of the force that you are comfortable with. So I'll choose the kilonewton option over here. So after that, click on next. So use the add beam option over here. The explanation of this option you can get over here if you want to read. So as I told you in the previous chapter, so add beam option is used if you want to draw a frame. So beam is also a part of the frame, so that is why we will use this option. So after that, click on finish. You will get this window over here. Just close it. There are few things that you need to know before you actually go into the modeling. Here you can see the axis that is used in the modeling. So let me explain this axis. Here we saw that we got the axis as, in this direction we got X, in this direction we got Z, and in the upward direction we got Y. So you can choose Z direction in the upward as well. Here in this direction, so this is the origin, and to the right of the origin we got positive X, and on the left of the origin we got negative X. So this is the negative X. Okay. Similarly, we got Z positive in this face, so that is the face that is coming towards you from the screen of your laptop or your computer, and the axis that is going away from you, that is the negative axis, negative Z. Similarly, upward axis is the positive Y, and the downward axis is the negative Y, negative Y. All right, this here is the origin. Okay, before we actually model our beam, we have to first define the nodes. So what are nodes and why we define it? Let us see. So let me delete this. This is the axis that it is shown in our window. All right, so this is X, this is Y, this is Z, and this is the whole lot of the interface. So suppose that you have to draw a beam of 5 meter size. So how can you do that? This is all blank space and you cannot draw a beam of exactly 5 meter size. But what if you could define a point here? All right, so you defined a point, and at a 5 meter distance you could define another point. So now all you need to do is join this point to this point, so that you could get a beam of exactly 5 meters. And if you want this beam to be extended to another 4 meters, what you can do, so if you could define a point here and you can connect these 2 points, then you could get a beam of 4 meters as well. The points over here, so these points that help or that guide you to draw beams, columns, or the plates are called as the nodes. So they are basically the joints, or you can say the points. Okay, so they rhyme with each other. So joints that will help you to draw the beams or the columns or the plates. They are the snapping points in your model. How do we define the nodes? We will see here. So let me delete this and deselect it. Okay, so we got the origin here. So we got the origin. So this is the positive X, this is the Y, and this is the Z. So it is very important to understand your axis system as well when you model your structure, so that you are modeling your building in the right direction. Okay, so this is your origin. We always define our first node at the origin. So we got the origin at 0, 0, 0. And suppose that we want a beam in the x direction. If we want the beam of length 5 meters, then in the x direction we have to define a point here just on the axis. So the coordinate of this point is, so in x it's 5, in z it's 0, and in y also it's 0. And if you want another point or another beam of 4 meters length, in that case what you can do, so you can define a point at a distance 4 meter from this point. So the coordinate of this point now becomes, this is 5 from here to here, and it is 4 from here to here. So 5 plus 4 give you 9. So in the z it's 0, in the y it's 0. But once you get these points, so 1, 2, 3 points, what you can do, you can simply join these points to draw the beam. And after drawing the beam, you can give the supports. So you can give the supports, and after that you can apply the loads, and you can analyze and design your structure. Let us consider a simple beam and apply the simple loads on that beam. So let me delete these things. So I'll draw a simple beam over here. So the beam over here, let us give fixed support on this end. So let's keep on drawing. Okay, here I'll give a roller, and here also I'll give a hinge. Here also I'll give a hinge. Let this span be 5 meters as I already told you. So let this span be 6 meters, and let this span be 4 meters. This is just an example. So what we're gonna do is that we will be applying a simple pointed force here at a distance of 2.5 meters. So at the center 2.5 meter, and here what we will do, we will apply a uniformly distributed load. Quantity of this load is, suppose it's 20 kilonewton. This UDL is 10 kilonewton per meter. And here what we will do, so we'll apply a moment at a distance of so this is 4 meters, so we'll apply a moment at 2 meters. Moment will be 5 kilonewton meter. In the next lecture we will see how we can apply the uniformly varying load of this kind as well. Let's model this simple beam in STAAD Pro and also apply the load. To do that, as I already told you, we have to define the nodes. So the first node that we will define is at this point. So this is the origin 0, 0, 0. Okay, and the next is, so the distance from origin, that is the origin is at here, and the next point is at a distance of 5 meters. So the coordinate of the next node that we want is 5, 0, 0. The coordinate of the next point that we want is, so 5 plus 6, 11, 11, 0, 0, and the next point is here. So the coordinate of the next node is 4, it's not 4, it's 4 plus 11, that is 15, 0, 0. Here we are just doing in the x direction. So later when we will do a frame, in the next chapter we'll do a frame, we will see in the x and the y the variation of the coordinates or the nodes. And in the next chapter you can see the very next chapter, yeah. So what we're gonna do is that we will model this frame, so where we will see x, y and z variation, and when we'll do our building, in that we will see everything. So let us go to the STAAD Pro program. So let us first define the node. So to define the node, you have to go to the geometry tab here. So if you are not, then you will see this window, just close this. So this is another method of drawing the nodes, but we will not use this method. So there is an easier method, that is we have to define the nodes. So here it says beam practice std nodes. So node number 1 is always at the origin, so click on 0. So automatically, so y and z are also given at 0 meters. So you can see a node has appeared over here. This is the origin of our structure. Okay, so the next node is at 5, 0, 0. Hit 5 and hit enter. So the 0 will automatically come. You can see the next node has appeared over here. The distance from here to here is 5 meters. Next node is at 11, 0, 0. So 11 and hit enter. You can see next node has appeared. Distance from here to here is 5 meters and from here to here is 6 meters. Earlier you saw a first node here, the second node here. Now what the software has done is that it has scaled this window so that the 3 nodes can adjust. Okay, so this is the first node that we created, this is the second node that we created, and this is the third node. Let us create the fourth node. So the fourth node is at 15, 0, 0. So after you type 15, hit enter. So now you can see that you got 4 nodes. Okay, so let me explain about the views in the STAAD Pro. So let me delete these things, so delete them. Let me talk about the various views in the STAAD Pro. For that, let me draw a cube. This is the back face. I'll show you with the dotted lines. Alright, so let us assume that, so this is the x-axis, this is the z-axis, and this over here is the y-axis. This face of your cube, so this face, this forward face, let me write the names A, B, let us name this C, D. So we'll do this E, F, G and H. So this A, B, C, D face, this front face shows you the view that you get when you look from here. So you look from here, so you will see the A, B, C, D. This view that you see is the view from the Z axis. You stand here and you look in this direction. Similarly, so this is the positive Z, and similarly the face that you see from the negative Z is E, F, G, H, G or GH, this face, okay, that you see from the negative Z. Similarly, if you stand on the x-axis and look in this direction, from the positive x-axis you can see B, F, H, C face. Similarly, from the negative x-axis you can see A, E, G, D face. Similarly, from the positive y-axis you can see the top view, and from the negative y-axis you can see the bottom view from here. These are the different views in the STAAD Pro. We have drawn our beam like this. We have not drawn, so we'll be drawing. So right now the beam that we see is in the isometric form, that we see the entire 3D view, isometric view, or the entire 3D view of our beam. So to just see the beam in our plane, what we have to do, we have drawn the beam like this. Okay, so we have drawn the beam like this. We have to see from the positive Z axis, we have to see from here so that we can see this entire beam in a plane. We're gonna change the view of our window. Just click on this window over here. Over here you can see a cube, and the face of that cube is colored. So you can see the front face is colored. That means that this is a view from the positive Z that I just show you. Similarly, this is the back of the cube from the negative Z. Similarly, from the minus X, that is the left side, this is the right side, this is the bottom, and so this is the top of the cube, this is the bottom view, and this is the 3D or the isometric view. Right now we want our beam to be shown on a XY plane. So to be seen in the XY plane or in this plane, what we have to do, we have to see from the Z axis. So what are we gonna do? We're gonna click on this option. So you can see that you saw your points or the points of the beam in a straight line on the XY plane. This is the X, this is the Y. So we are still looking from the Z axis. So if I change this to isometric form, you can see that now the axis has also changed over here. So X, Y and Z, all three axes are clearly visible, which means that we are looking in the isometric or the 3D view. Just click on this again, this view from Z option. You can see this Z view. After drawing the nodes and understanding the view in the STAAD Pro, let us draw the beam. To draw the beam, what you can do is that you can either go to geometry, so geometry option over here. After that, go to add beam and click on add beam from point to point. You can do this, or what you can do, you can see that the icon that is available here, you can see the same icon over here as well. So which means that instead of going to the menu bar, you can access this option from this toolbar as well. We will use the shortcut option. Let us draw this from the toolbar. So left click on this icon. After that, click on this node, left click. So drag your mouse, take to the another point and left click on this node. So once you are done, again left click on this node, and after that left click on this node. So now you can see that you have drawn two beams. Similarly, left click on this node and after that left click on this node. Okay, so we have drawn our three beams as per our practice file. So here we are at the geometry and we are done with the beam. We don't need anything else from here. After drawing the beam, let us go to the general tab. Just click on the general tab available here. So left click on it. Now let us define the section of our beam. Click on this property, or it is already activated. After that you can see that we don't have any section over here. So what we're gonna do is that we will be defining a new section. For defining a new section, so click on define option that is available here. So left click. So you will get this window. So we are defining a rectangular section. Let us click on rectangle and let us assume that the depth of this beam is 300 mm, so 0.3 meters, and the width of the beam as 200 mm or 0.2 meters. Material over here is the concrete. So this concrete material has been defined by default. So after defining the rectangular concrete beam section, so what we're gonna do is that click on add. So you can see that you have added a concrete beam. Here we are defining the concrete beam of a single type. So if we happen to define beam or the column of different sizes, then we can keep on adding our beam sections. So now we click on close, left click. Now we have defined our section. Now we have to tell STAAD Pro to assign this member or this section to the beam that we just drew or model. So what we're gonna do, so we will first select all these beams. You can just left click here, anywhere here, and drag your mouse, cover all the beams with this box and release your left mouse button. You can see that all the beams have been selected. Here we got different options to assign. So assign to the selected beams. So we have selected the beam, and if we click on assign and after that click on yes, you can see that we have assigned this section to the beam that we drew earlier. Now all these beams are of size 300 by 200 mm. So this is one method. There are other methods, so we will see those methods also in the coming lectures. We have drawn a beam. So next thing that we do is we provide the support to the beam. Click on the support option. Here we actually got 3 beams. Right now we don't see So what we're gonna do is that we will display the nodes so that we can differentiate our beams. To display the nodes, just press shift and press K. So shift plus K, if you press, so it will give you the nodes. Okay, so this is a way. So another way is you can see this option over here, so symbols and labels option here. Just left click on it. On the labels tab, over this nodes option, just press node points and you will get these node points. And if you want the node numbers, just select this option and click on apply. You can see the node numbers as well. So this is node number 1, node number 2, similarly 3 and 4. And after that, click on OK. Here in this example, so we got a fixed support at this point. Okay, we got a roller support at this point, we got a hinge, and we got another hinge here. We will define these supports. So for defining the supports, click on create option that is available here. So we are at the general tab in this support sub tab. So click on create. This is the fixed support. On the fixed support, fx, fy, fz, mx, my, mz. So the translation in the x direction, translation in the fy direction, translation in the z direction. Similarly, rotation in the x direction, rotation in the y direction, and rotation in the z direction is restrained or prevented. So this is the fixed support. So we will click on add. So next support that we are doing is, so let us define the hinge supports first. So let us click on create, and over here let us click on the pin support. So the pin support, the restraint, the translation is prevented but the rotation is allowed. So what are we gonna do? We will click on add. Similarly, let us define the roller support. Click on create again. You can see that we don't have any option for the roller support. For that we have to use fixed, but in the roller support what happens is that this is your roller support. So in the roller support you can go in this direction, x direction, you can go here also, you can go here, you can go here. So the release or the degree of freedom is in the x direction, z direction. Okay, so you can move in the x and the z direction, but you cannot go up or down. The restraint is in the y direction. Similarly, for the movements, the roller support, you can rotate in the x direction, you can rotate in the z direction, or you can rotate in the y direction as well. Rotation in the y direction means that rotation about the y axis. Similarly, rotation in the z direction means that rotation about the z axis. So rotation about y axis means that, so this is our roller support. Okay, this is the ground and the y axis is the vertical. If we apply the movement like this, okay, movement like this, so this will rotate like this. Okay, so this will rotate like this. So this is the rotation or my movement. Okay, so here only the translation in y direction is prevented, and all the other things my, mx and mz, these all things are allowed. All right, so we got releases in the x direction, that is it can translate in the x direction to and fro. So we got releases in the z direction, it can go to and fro in the z direction. Similarly, rotation about x direction, y direction and z direction is allowed. Only the movement in the upward and the downward direction is not allowed. So we click on add. So now what we do is, if you select this node here, if this node selection option is not activated, okay, so let us save this, it's not activated, what you can do, you can click on this option, nodes cursor option here, to select the nodes. So if you use this option, then you won't be able to select the nodes, but you will be able to select the beams only. So to select the nodes, you have to click on this option. So let us select the node here. We saw one option of assigning anything to the other thing, that we select the thing that we want to assign. So we want to assign the support to. After that, we select the thing that we want to assign it to. So we want to assign it to node 1. After that, we check this option, assign to the selected nodes. and we click on assign, and after that we click on yes. So you can see that the fixed support has been assigned. So the next option is that assign to view. So if we use this option assign to view and check this option and click on assign, all these nodes that are in this view, they will be assigned the fixed support. So we will not be using this option. So next thing is the use cursor to assign. If we check this option and after that click on assign, so wherever we click on the node, the fixed support will be assigned. So we don't want the fixed support here, so we want the roller support. So what are we gonna do? We click on this support 4. After that we come here and click on this node 2 to get the roller support at this node. Similarly, after that we click on support 3, we click on here to get the hinge support, and we click on here to hinge support. So we don't need these node numbers here. So what we're gonna do, we will be selecting this option, click on this left click, symbols and the labels. After that uncheck this node numbers option. After that click on OK. So you can see the supports have been applied. After applying the supports, now we will give the loads. Let us click on load and definition. We are in the general tab and load and definition sub tab. So click on load and definition. Here you can see definitions, load case details and load envelopes option. We have to define the loads that we want to assign to our structure or to our beam. So for that, left click on load case details option here. So this option is used to define the new loads, and after that click on add option here. So left click, and this is the primary load that we are applying. So this is not any load combination. Okay, so this is a load. So this is the load number 1 and the title is the dead load. So let us apply the dead load, and the loading type is the dead. Okay, so in a building we know that we got different kinds of load. So we got dead load, we got live load, we got earthquake load, we got snow load, we got wind load. So this dead load will incorporate all the dead loads that are applied in our building. We click on add. The next load that we define is the live load. So let us define the live load. So the loading type is live. Click on add. So here we will apply only the dead and the live load. So we click on close. Here we have only defined the types of the load that we will be applying. We haven't yet applied any kind of load on our structure. In the dead load type we got various types of load. So here we will apply the self weight first. Let us click on dead and then click on add. So from here you can define the various kinds of load that you want to apply. It is the dead load. The load that we are applying is the self weight or the self load, and the direction is the y direction, and the factor is -1, which means that the self weight of this structure or the structural member will be calculated by the software itself. So how it will do that? For example, if this is your beam, so this is the section of the beam that we defined. So this is 0.3 and this is 0.2, and the length of a beam is 5 meters. So its volume turns out to be 0.3 into 0.2 area of this cross section times this length, that is 5. So you can get the volume. And the unit weight of concrete is 25 kilonewton per meter cube. The weight is the unit weight. So let us see, this is gamma and this is V, gamma times V, because 25 kilonewton load is contained in 1 meter cube of the concrete, which means that this volume of concrete weighs 25 times the volume. Alright, in this way the software will calculate the self weight of the structural members. Upward direction is the y direction. Okay, we got the weight and we have to apply the load in the downward direction, so the self weight must be applied in the downward direction, which means that we have to apply the load in the, so this is the origin, in the negative y direction. Okay, and so whatever the value we get, so we get this value, and if we multiply this with -1, we will get -25V of the weight. So -25V means that it will be applied in the downward direction, so that is why factor -1 has been taken. So if we take the factor as 0, then the self weight of this structure will not be considered. So that is what we basically do in our preliminary structural analysis of the beams and the frames, right? We don't consider the weight of those structural members, but here we will consider the weight of the structural members. That is why, so we will multiply the self weight with -1. So let us save it. So factor is -1, direction is y, so minus gives the negative direction, that is the downward direction. So click on add and close it. Now the 20 kN point load here, 10 kN per meter uniformly distributed load here, and a 5 kN meter moment here. We can either apply those loads as dead or the live. In the building, the dead and live loads are clearly defined. What load you want to apply as the dead, what load you want to apply as the live. But here in this example, you have the liberty to choose. So here we will apply those loads as the live loads. You can see that a question mark is here in the self weight, which means that we have told the software that we are applying the self weight, but where we are applying or in which structural member we are applying, we haven't yet told the software, which means that we haven't yet applied the load. So we'll do this in a while. Before that, let us define all the loads that we will be applying. So left click on live, and after that click on add. The first load that we are applying is the point load. So this is a member load that we apply on this member. So left click on this member load option here. So you can see that different options are available here: uniform force, uniform moment, concentrated force, concentrated moment. So uniform force is the UDL, so then we got the uniform moment. Similarly, we got the concentrated force, which is our point load. Similarly, concentrated moment, that is the point moment. Linearly varying force, that we will see in the next chapter. So left click on the concentrated force. The concentrated force we are applying is, the value is 20 and the unit is kilonewton. So here you can see the D1 and the D2. So D1 means that so this is our beam. Okay, oops. So this is our beam, this is our beam. So this is the first point of the beam and this is the second point of the beam. So this is also known as the local axis. Okay, so for this beam, this is the origin and this is the final point. Alright, so this is the local axis, and whatever we do in our model is the global axis. D1 distance means that at what distance from the origin of this beam, okay, not from the origin of the entire structure, but from the origin of this beam, you want to apply the load. That is your D1. Here we want to apply the load at a distance of 2.5 meters from the face of this beam, which means that D1 is 2.5 meter. And D2 means suppose if this is our center, from the center at what distance towards the face of the beam you want to apply the load. So we want to apply the load at the center, that is why D2 is equal to 0. So let us go to STAAD Pro. So D1 here is 2.5 meters because we want to apply the load at 2.5 meters from the face of this beam. Okay, so this beam, the direction is GY, that is the global axis. This GY is positive and it is positive in the upward direction, which means that this load will be applied in the upward direction, but we want the load to be applied in the downward direction. that is why we will put a minus sign here. After that, click on add. So here you can see that we have added a concentrated load GY -20, that is downward direction, at a distance of 2.5 meters. Okay, next load that we are applying is the uniform force. So here the uniform force value is minus, because we are applying in the downward direction, 10 kilonewton per meter. So D1 is the distance from the face of the beam. So let me sketch this again. You can see that this is our beam. So suppose that you are applying a UDL at a distance 1 meter from the face of the beam. So from here you are applying the UDL, and the length of this UDL is, suppose it's 2 meters. In this case, so this 1 meter is our D1, this 2 meter is our D2, and D3 we know. So if this is our center line, and at what distance from the center line to the face you want to apply your UDL. In this case, D1 is 0, so D2 also you can say it as 0, so which will mean that, so the software will understand that you want to apply this throughout, and D3 will also be 0, which means that we are applying the load at the center line of the beam. So we have said we are applying the load of -10 kilonewton per meter UDL. So all these distances are 0, and the direction is GY, global Y coordinate, and we click on add. So we have applied the load uniform GY -10 kilonewton per meter. So next thing that we are applying is the concentrated movement. So it is not a distributed movement, it is the concentrated movement. So left click on this. The value of the concentrated movement is 5 kilonewton per meter. Let us again understand the convention of applying the moment. So this is our beam. So this is our beam, okay, and we're applying the moment in the clockwise direction, all right, at the center. So this distance is the D1. So from this end, so this end is the known as the I end, and this end is known as the Z end, okay. And in the node term you can say that this is node 1, this is node 2, just an example. So in our example this is node 3 and this is node 4, all right. Okay, so this distance is the D1 distance, and as this beam is of size 4 meters, in our case the D1 distance is, as we are applying the moment at the center, D1 is 2 meters, okay, and D2 is at what point from the center line to the face you want to apply your moment, okay. In STAAD Pro, the clockwise movement is taken as negative, and the anti-clockwise movement is taken as positive. So this is just an convention, so you have to remember this, okay. Let us give these information. So D1 is 2 meters, and as our movement is clockwise, so we will write -5. And also talking about the direction, so as I already told you, so this is our beam, and this axis is our x-axis, and this axis is our z-axis, and this axis is our y-axis. As you can see that this movement is being applied along the z-axis, okay. I told you in case of y-axis, so if this is your axis and movement is acting like this, so which means that the movement acts about the y-axis, so perpendicular to the axis, okay. So here you can see that this movement is perpendicular to the z-axis, which means that it is being applied on the z-axis. So we have to apply this about the z-axis. So GZ -5, 2 meters, click on add. After that, close this. Now what are we gonna do? We select this self weight. So the self weight we are applying in all our structural members. So we select this self weight and click on assign to view. We check this option and we click on assign and we click on yes. So you see that the self weight has been applied, which is denoted by this red color. After that, click on this -20 kilonewton load. So we are applying this load on this beam, so select this beam. Okay, so only this beam should be selected. Again, select this load, and after that click check this option, assign to the selected beams. So click on this option. Okay, and after that click on assign and click on yes. You can see the load has been applied and arrow is very long, so this is due to the scaling. What we're gonna do is that we will scale down this load arrow. For that, click on this option over here, symbols and labels. So left click, and after that click on scales. So here point force, so let us increase the scale and use this option, apply immediately. So check this and keep on increasing this value. You can see that the scale has been increased and this arrow decreases. So click on apply and click on OK. Now let's apply the UDL. Left click here, select the load that you want to apply, and after that click on assign and click on yes. You can see the UDL has been applied on this beam section. So next load that we apply is the moment. To apply the moment, click on this beam, select the moment, load, and after that click on assign, and after that click on yes. So you can see all the question marks have gone and changed to some greenish colors, so which means that the load has been applied. You don't see the movement here, so this is due to the scaling. Left click here, symbols and labels, and go to scales and check this option, apply immediately. So point movement, so increase the scale. Okay, alright, keep increasing the scale. So now you can see the movement here as well. So click on OK. So you can also define the material. So here we have defined the concrete, but we haven't told the grade of concrete. So by default the concrete has been defined, and if we click on edit, so we cannot edit it. You see that the grade of concrete that is used is 27579 kilonewton per meter square, which is 27.5 or 27.579 megapascal or 27.579 grade of concrete. What if we want this grade to be M20, M25, M30? So in that case we can define the concrete of our choice. We will learn this thing when we model the building. Okay, so just click on OK. We will just use this grade of concrete right now. So after doing this, we analyze our structure. So for that, click on analysis print tab here, and you can see this window appears, and print option, no print, load data, static check, static loads. So this means that whether or not you want these things to be printed. So right now we don't want this thing to be printed in our result window. We'll click on no print and we click on add. So after that click on close. After that go to analyze option that is over here. So analyze menu. So left click on analyze and click on run analysis. So click on save. You can see that STAAD Pro has started analyzing our structure. So here we see 0 errors, 0 warnings, 0 notes. If we see any errors over here, 1 or 2 errors, it will list what error is that, and after solving those errors only you can move forward. If you don't solve those errors, you cannot move to the post-processing works. So if you want to view the output file, so check this option and click on done. So here the output file is displayed. This will show you all the inputs that you gave. So joint coordinates and the member incidences. So joint coordinates means the coordinates of the nodes 1 0 0 0. First node is at 0 0 0. The second node number 2 is at 5 0 0. You can see the joint coordinates. Similarly, member incidences means that the first member is from one node to the second node, second member is from the second node to the third node, and so on. Alright, so if we go down here, you can see, actually you cannot see anything because we chose no print option. Okay, so let's just close this. So after analyzing our structure, let us see the bending moment and the shear force diagrams. For that, we will go to the post-processing mode. Left click on the post-processing mode. So here the selected loads are dead and live. So if these loads are here in your case, just okay, so just get these loads here. All right, these two loads should be on the selected portion. So click on OK. Here you can see a node, a beam, and animation and the reports. So node means that if you want to see the node displacement or the reactions at the nodes, if you click on a displacement option, you can see that you can see the results here. So node 1, so this is our node 1, node 2, node 3, node 4. So we got two load cases, dead and live. Displacement and the rotation of each node or each node is 0 because it is at the support, and the supports don't give any displacement. Okay, so let us see the reactions. I'll just click on the reactions. So this is the reaction in the x direction. Upward reaction is 5.753 kilonewton. Similarly, moment mz is 5.457 kilonewton meter. That is in the anti-clockwise direction. So here the support reaction at x and y z direction is free because it's a roller, and the upward reaction is 45.576 kilonewton, and there is no moment. Similarly, these two hinges, the moment is 0, and the upward reaction is 32.100 kilonewton and minus 3.429 kilonewton, which means that the reaction is downward at this joint. Okay, so after seeing the reactions, let us go to the beam tab. So here you can see the bending moment. You can see these results in a different manner as well. So let us maximize this window. You can see the bending moment diagram. So click on results menu over here. So click on results and click on view value, and here click on reactions. The reaction that we want is global Y because we got only the upward reactions, and the bending that we want is global RZ because the moment that we got is in the Z direction, and we click on annotate. So by doing this, you can see the reactions, that is the upward forces, and the movements, that is the movement along the Z direction. Click on remove all, and if we click on beam results, from here you can see the bendings, shear force, axial force, displacements. Okay, if we see the bending and if we see the maximum value, check this at the maximum and click on annotate. You can see the maximum value of the bending at each point. Right now just close this. So right now you can see that the movement diagram is not clear. For this we have to scale the movement diagram. So left click on this option, and after that go to scales. After that check this option, apply immediately. So in the bending is in the Z direction, we want to make this one look bigger, so we have to decrease the scale. So let us decrease the scale. So now you can see clearly the movement diagrams. Click on OK. So this is one way, and the other way is, so hold Control on your keyboard. After that the middle mouse button or the wheel on your mouse, just scroll it. Okay, and if we scroll it clockwise, so the size of the diagram will increase, and if we scroll it anti-clockwise, the size of the diagram will decrease. This is how you see the bending moment diagram. Another option to see the bending moment diagram is from here. So right now we are seeing the bending moment in the Z direction, that is bending Z moment. If you want to see the bending Y moment, click on this. So there is no bending Y, and uncheck this. Okay, so you cannot see anything. Similarly, if you click on FY, that is the shear force in the Y direction, and you can see it hasn't been scaled. So uncheck the MY option here. So let us scale it, Control and middle mouse button. You can see the shear force diagram. To see the value of the shear force, what we do, we go to results and we go to view value here, the view value option here, and go to beam results. We want to see the shear at the ends, so we don't want the movement right now, and we click on annotate. You can see the value of the shear force at the ends. So if you want to see the maximum, then check the maximum option, uncheck ends. You can keep the ends as well, click on annotate. So the maximum value of the shear force you can see here. Similarly, you can see the shear force at the midpoint, and also you can see the moment diagrams. Okay, and let us close this. If you double click on a beam, so let's just double click on this beam, you will get this window. So here it talks about the geometry, and the next tab talks about the property of this beam. Okay, the size. It talks about the loading, the kind of the loads that have been applied. So the dead load, we have applied the self weight, and the live load we have applied the point load. Okay, similarly it talks about the shear and the bending. So here we want to see the bending in the Z direction, and if we scroll this to the right, then you can see that at distance this meter 0.880, you can get Fy, that is the shear force, and also you can get the bending moment. Using this option you can find the bending moment at any distance that you want. So similarly, if you want to see the shear force diagram, you can see the shear force. So, and if you scroll, you can see the shear force value at various locations. Similarly, you can see the deflection. Here there is no deflection in the X direction, the deflection is in the Y direction. So check this option. You can see the deflected shape of the beam. Okay, so you can find the deflection at the various points, and the maximum deflection is 0.161 mm. Click on close. In this way you can analyze your beam and see the results of the analysis. And here this is the animation option where you can animate. Right now this animation is not working in my software, I don't know why, but just choose the option that you want to animate, so deflection, and click on OK to animate the deflected shape. Finally, we can prepare the reports. Alright, so based on the job information that we gave earlier, and also for the beam, you can take these the snapshot of these pictures within the software using this camera option that is available here. Alright, and based on this information, software will prepare the reports. You can try these things on your own. Alright guys, so this much for the beam, and in the next chapter we will learn how to model and analyze a frame.